The Accord demonstrations in Finland were implemented in 2 ongoing construction projects where all 4 Finnish use cases were evaluated. This video covers 3 of those, and the 4th one, CO2 calculation, is in another video. Both projects were courthouses, one in city of Pori and other in city of Vantaa. Pori Courthouse is new building, and in Vantaa was new building construction and renovation of existing part seen with blue facade on the right in the figure. The owner of the buildings is Senate Properties, that is managing the state's building properties, and client is Ministry of Justice. Senate Properties invited the project stakeholders for demonstration, especially the architect consultants, which are typically owners' representatives in permitting activities and, of course, in creating a BIM model for the permitting process. In both cities, the local building control authorities were interested of the demonstration and attended in the work. In both projects, the building permitting phase was during Accord project, but permitting was done with current practices due to the schedule requirements of the project. The Pori demonstration was implemented about 1 year earlier than Vantaa, and initial experiments were done with some available desktop tools, but in both cases the Accord results were tested in early 2025. The first Finnish use case covers retrieving and handling general official information of the building and construction project. This use case 1 concentrates in validating IFC data that need to be provided with permit application to be later transferred to National Building Registry. In current practice, there is national XML schema for the data and that have converted in national IFC property sets, enabling inclusion of official building and construction data in the permitting BIM file. The data validation covers checking that correct property types are included, and data values are following enumerations if those are given. The basic setup in Finnish demonstrations is that Cloud Permit Service, number 5 in the figure, is providing user interfaces to applicants and authorities and collecting all needed information in the permitting process. Cloud Permit Service is calling Solibri Cloud Checking Service for IFC data validation and compliance checking. The national IFC data definitions for building registry data are not yet online. Data dictionary and definitions are hard-coded in the systems. However, it is expected that in near future the all building permitting and related IFC data definitions are up-to-date, available in National Data Dictionary Service, and can be utilized in validation services. The use cases 2 and 4 for accessibility and operational safety are following the same demonstration procedure, and both are presented here in parallel. In these use cases were checked selected 6 clauses of accessibility and operational safety decrees. The clauses were converted with Accord rule formalisation method into BCRL format and presented with YAML serialization. In Solibri Cloud Checking Service was developed a method to run compliance check of each BCRL rule. This was successful proof-of-concept testing for BCRL methodology with real-world regulation and building data. The demonstration of these use cases implemented with same setup of Cloud Permit and Solibri components as the Finnish use case 1. In these use cases, Cloud Permit sent to Solibri Cloud Checking Service the BIM file and BCRL rule set of the selected clauses. Also, the rule set for IFC validation was included to make compliance pre-check of IFC data. The Solibri Cloud Checking Service responded by sending checking results in BIM collaboration format BCF, where each result were defined as a BCF topic. Cloud Permit stored results and reported the findings in the user interface to the applicant or authority. The following slides present feedback received from demo project participants after the demonstrations. The demonstrations were organized as 2 online sessions for Pori and Vantaa projects. In both sessions were attending the local building authorities, architects, owner, and some other stakeholders like BIM coordinator and few other building control authorities. The permitting procedure was evaluated with sharing a view in Cloud Permit user interface. The main functionalities were demonstrated, and those were uploading model, 3D viewing, pre-checking IFC data, compliance checking, and nonconformance management. Some functionalities in the service were experimental at time of demo implementation. The attendees' feedback was collected in separate interviews afterwards. Although the demonstration also covered the technical testing of the developed Accord components, the following feedback highlighted mostly the participants' perception of the operational process and user interface of the service. By the authorities, the general feedback was positive and the service was perceived as functional and easy to understand, although some improvements were suggested. At start of 2026 in Finland is required in bigger projects to provide also a BIM for permitting authorities. So the authorities are interested of the topic and have some concerns of the implementation in practice. It is expected that it will take some time to reach the full potential of BIM-based automated compliance checking. The automated checking was considered helping in routine checking, leaving time to more important authorities' tasks. Also, this automated routine checking will be more comprehensive than earlier. The feedback indicated that it is too early to evaluate reliably total benefits or impacts. It was expected that there won't be big impact in total application processing time, as automated checking is only part of the authority's work in permitting. Applicants' self-service for model pre-checking would improve BIM quality for application. This will help authorities to reach the coming 3 months time limit for permit processing. It was also expected that some design errors may be reduced as the modeling need to be done more systematic way. Education and training needs for the authorities are obvious, but this was seen to happen in phases on longer period. There is also need to provide more information of BIM usage to the applicants. The new BIM functionalities will add some cost in the current permitting service, but on the other hand was considered that in basic permitting cases no other BIM software would be needed. BIM usage in permitting was seen also supporting in creating more detailed 3D city model, enriching the rough point cloud-based city models. In cloud permits, 3D BIM viewer is needed, some typical features existing in other tools like using section planes. The UI will be developed further according to user feedback. The architects considered the new BIM functionalities in cloud permits permitting service promising in general. As architects have experience of model checking, some concerns were made on how to handle efficiently if a lot of repeating nonconformances is found. There is also need to make beforehand a note to authorities for minor deviations, which would save time for both. It is obvious that adding systematically more detailed information in the model will require more work. On the other hand, the BIM information would be more consistent, and it could support also other needs in the construction project. The practices to input required information in the native authoring software and get in correct format in IFC requires development. In demonstration projects were done quite a lot trial and error efforts to solve this. Also, there were some conflicts in classifying building objects with current method used in architectural modeling and new required IFC method. In general, as authorities, the architects saw the change toward BIM-based permitting method will happen over longer period for very practical reasons restricted by competence and available resources. Some issue was seen in that building permit application is usually targeting to meet minimum requirements of regulation, even in cases that client sets higher requirements in contracts. This gives some flexibility if requirements needs to be downgraded for some reason during the project. This has been easier in document-based design. As BIM is considered as single source of truth, it may be difficult to maintain different requirements for different purposes. The demonstration focused on compliance checking for building permit application. It was pointed that the permitting service could be also used in building's landscape evaluation phase before the application is sent. There are opportunities to attach an early phase 3D model in the city model for these evaluations, as have been done in some other cases in Finland. Thank you for your attention. Here are the contact persons for details of the Finnish Accord demonstrations. You can follow Accord project on social media and visit our website.